All right, so in last video, we talked about some of the failures of classical physics, and in particular, 3 different experiments listed here. And we talked about the first one, blackbody irradiation, and how this eventually led to quantum mechanics. But we had to take a little bit of detour before we discuss the other 2, the photoelectric effect and the hydrogen line spectrum experiments, because we have to talk a little bit about the nature of light and the quantized nature of light. So that's what this slide shows you about. So it turns out energy is not continuous. It is discrete. It is quantized. It occurs in steps, okay? It is more like a ramp. It is not like a ramp, okay? It is more like stairs, okay? And so you can only have certain values. So for example, let's say you had a value of 1 in some energy units and a value of 2 in some energy units. You could have a value of 3, but you couldn't have a value of 1.5 or of 2.5. That would be just forbidden by the laws of quantum mechanics. It occurs in discrete steps, okay? And so this is a very interesting and bizarre kind of property of the universe. And so how do we actually talk about that? Well, if we're talking about changes in energy, that's going from one step to another. And so that's shown by this delta E equation, change in energy, right? And we have N times H times nu. Looks like a V, but that's actually a Greek letter called nu, spelled N-U, okay? If you call it a V, it doesn't really matter, all right? But just so you know, it's nu. And nu is the frequency of light that's gained or lost, right? Either absorbed or emitted during this process. And H is a constant, okay? And this constant was discovered by Max Planck, okay? And so it's named after him. It has units of joule seconds. You'll notice it's very, very small. It's 6.626 times 10 to the minus 34. So it's a very small value. And because it's so small, we don't notice these stairs in our life, the stairs in the energy landscape day to day. They're too small to make a difference for most things, okay? Now, on the atomic level, which is a lot of what we're dealing with when we're talking about chemical processes, of course, it does matter. And this is why we need to know about this. And a lot of technologies and other processes that have to do with information being stored or processes on the atomic level, quantum mechanics is needed in order to have the proper functioning of those devices, okay? But essentially what you're looking at is this change in energy is equal to N times H times V, and N is an integer. N is gonna be -1, let's say, 0, 1, 2, 3, but it couldn't be any fractional values. That's what this N value tells us. It tells us that we live in a life of stairs, okay? Now you can use this equation on the right, and we'll be using that quite frequently when we're calculating the energy of a certain frequency, right? Because we have Planck's constant, it's always gonna be given to us. That's always known. That's a fundamental constant of the universe. We have frequency. So yeah, that's really how I want you to think about it, is life turns out to be stairs. It's not a ramp. And this is not at all obvious. Going any deeper than this, we can't really. This is, we're getting to the deepest kind of principles of the universe as we know it, okay? And this is just at the heart of quantum mechanics and the universe. So a little bit of an aside, I like this photo because we have, a lot of different really famous and Nobel Prize winning chemists here. 5 different Nobel Prize winners are at this table. And what do you know is, they're talking to each other, and this is how science goes forward. People communicate, and the best scientists in the world talk to one another. And so this is just one of these things, like, don't be intimidated by people who are smarter than you, or at least people who you think are smarter than you. How we define intelligence, of course, is difficult, and that's a whole other subject. But, if you want to become the best basketball player in the world, what are you going to do? you're going to go to LeBron James, right? You're going to go to Michael Jordan if you could, right? That would be the best. Those would be the best people to learn how to become the best basketball player. So any opportunity you have to be around people who are more knowledgeable than you or who you think are smarter than you, that's a great thing to do. All right, so that kind of wraps up this short little video on the nature of how light is quantized.